Assalamualaikum warahmatullahi wabarakatuh. So today our group will present about the water flow measuring system. Eh, Yeah. So our group consists of me, Muhammad Fidul Muhammad Sharif, and then Amirul Mukmin bin Baharudin, Ibrahim bin Muhammad, Syahiman bin Rosli, and Ridwan Hanif bin Jalil. Okay, now we will proceed with characteristic of flow rate sensor. Okay, so at the first point, flow rate sensor is considered as a Hall effect transducer. Actually, there's many type of transducer in the industry nowadays, and Hall effect transducer is just one of them. And what is a Hall effect? It will be explained later in this video. So stay tuned. Okay. Okay, for the second point, flow rate sensor is both primary and secondary transducer. How? Why? This is because flow rate sensor is constructed by two type of transducer. Yeah. So for primary transducer process and secondary transducer process, we all know that primary transducer will convert physical quantity into mechanical signal, and secondary transducer convert mechanical signal to corresponding electrical signal. Okay. So in this case, for flow rate sensor, primary transducer will convert the rotation of the rotor into magnetic field magnitude. Okay, and for the secondary transducer, it will convert the magnetic field magnitude into voltage, where the voltage will be directly proportional to the magnetic field magnitude. Okay, for the third point, since flow rate sensor require external source of power, so it is considered as a passive type of transducer. And for the last point, flow rate sensor is considered as a both analog and digital transducer, since it changes the input quantity into continuous function, and it also changes the quantity into digital signal or in the form of pulse. Okay, so for the characteristic of flow rate sensor has been explained. So we'll proceed with Mukmin. Okay, Mukmin, tafadhal.
Okay, terima kasih kepada rakan sekerja Muhammad Firdaus bin Muhammad Sharif. Ya, Assalamualaikum warahmatullahi wabarakatuh. Okay, pada part saya akan menerangkan pada anda semua model yang digunakan dalam projek kami instrumentation dengan beberapa spek dia. Okay, model yang digunakan adalah YF S201 Hall Effect Water Flow Sensor. Okay, dia ada banyak model dekat dekat pasaran. Tapi kami pilih model ini kerana ia lebih berketepatan dengan projek kami. Okay, water flow sensor YFS 201 consists of a plastic valve body dengan bertujuan untuk mengawal kadar saliran air yang akan masuk ke dalam sensor tersebut. Okay, seterusnya ada water rotor atau nama lain ialah pinwheel. Pinwheel ni akan digunakan untuk detect speed air yang lalu kat dalam sensor tersebut yang akan dibaca oleh Hall effect sensor. In this project, we connect with the Arduino. So the main reason we choose this sensor are because the sensor has a digital interface which make it simple and easy to connect it to a microcontroller which is Arduino. So sebab tu kami pilih sensor ini kerana ia sangatlah berketepatan dengan projek kami. So nama pun dah water flow sensor. So mestilah sensor ini sentiasa attached in the liquid system. Alright, next, the sensor comes with 3 type of wire, which is red, black and the lastly yellow, seperti yang tertera kat dalam rajah di atas. Okay, the red one is a positive wire, which can carry out 5 to 20 volt direct current power. Next, black is a ground wire, and lastly is yellow, which is Hall effect pulse output. So apa yang dibaca oleh Hall effect sensor dalam model ini akan di carry out by the yellow wire and will be attached to your computer and will come out the result on your screen computer. Alright, for the last of the slide is the spec of the model YFS201 Hall effect water flow sensor. Okay, the working voltage is 5 to 18 volt DC current. Okay, minimum tested working voltage is 4.5 volt. Maximum current draw is 15 milliampere or 5 volt. Output type is 5 volt TTL. Working flow rate is 1 to 30 liter per minute. Working temperature range is negative 25 to positive 80 degrees Celsius. Working humidity range is 35% to 80% relative humidity. Next is accuracy is plus minus 10%. Next is maximum water flow pressure. Water pressure is 2.0 megapascal. Output duty cycle is 50% plus negative 10%. Next is output rise time is 0.04. Output fall time is 0.18. Flow rate pulse characteristic is equal frequency is equal to 7.5 times flow rate. Okay, and this is a type of formula for flow rate pulse characteristic. Next is pulse per liter 450. Durability minimum is 300,000 cycles. Cable length 15 cm. Ini tak pasti sama ada depends pada kedai untuk jual 15 cm ataupun memang fix 15 cm. Okay, seterusnya ada half inch nominal pipe connection, 0.78 inch outer diameter and half inch of thread. Kemudian last kali ialah size dia adalah 2.5 inch times 1.4 inch times 1.4 inch. Okay, untuk size dia tak adalah besar mana, mungkin besar tapak tangan kita. Mungkin macam itulah kita boleh anggarkan. Okay, selesai part saya. Okay, saya akan serahkan kepada Syariman untuk terangkan working principle water flow sensor. Silakan Syariman.
Okay, saya akan terangkan mengenai working principle of water flow sensor. Okay, water flow sensor consists of plastic which water can flow past. The sensor is put to measure the flow rate or the quantity of water passing through the pipe. Okay, sensor ni diperbuat daripada plastik mostly kan. So kita gunakan sensor ni, kita akan pasang dekat pipe, macam pipe kat dalam rumah tu. Kita akan bila pipe tu air lalu kat dalam pipe tu, sensor ni akan kira dia punya berapa banyak air yang terlalu kat dalam pipe ni. Okay. So kita teruskan. When the liquid push against the fans of the rotor, it will cause it to rotate. The shaft of the rotor is connected to the Hall effect sensor as in figure. Okay, macam kat figure sebelah. When the rotor is rotated due to the flow of water, it will induce the voltage. This induced voltage is measured by the Hall effect sensor. Okay, apabila air lalu macam gambar sebelah ni, air lalu dia akan rotatekan rotor tu. Tu magnet yang dekat setiap rotor kat atas tu, dia akan lalu kat Hall effect sensor tu dan dia akan create pulse. Okay, kita teruskan. The number of pulse were measured using an Arduino ataupun microcontroller and then calculate the flow rate in liter per hour using a simple conversion formula. The connection of flow rate sensor to Arduino as in figure kat bawah tu. So macam mana nak dekat dalam sensor ni juga dia ada 3 wire. 3 wire tu kita connectkan macam dekat gambar kat bawah tu. Kuning kat atas tu, hitam dengan merah kat bawah tu. Okay, lepas tu when the Arduino detects the pulse, it immediately trigger the pulse counter function. Then the output of flow rate will be display on the laptop or PC. So sebabkan kita dah connect, so sistem ni akan keluarkan input dia ataupun kita connect dengan PC dan dia akan keluarkanlah flow rate dan nilai-nilai flow rate dan volume yang telah lalu ke dalam pipe tu. Itu saja. Okay, saya akan serahkan kepada Ridwan untuk explanation seterusnya.
Okay, seterusnya kita akan sambung dengan Hall effect. Okay, what is Hall effect? Hall effect is triggered by the existence of a conductor's current. Hall effect sensors are linear transducers which are used to measure the magnetic field magnitude. When a magnetic field is detected, these sensors generate a Hall voltage which is used to measure the magnetic flux density. The output voltage of this sensor is directly proportional to magnetic field magnitude. The range of magnetic fields can also be measured by linear sensors. Furthermore, proximity, position and speed also can be detected by using these sensors. So makna kat sini Hall effect ni terjadi dengan kewujudan current dalam konduktor. Hall effect sensor ni juga boleh digunakan untuk mengukur magnetic field magnitude. Sensor ini juga boleh menghasilkan Hall voltage bila magnetic field dapat dikesan. Hall voltage tu juga kita guna kita boleh guna untuk measure magnetic flux density. Hall voltage tu juga dia directly proportional to magnetic field magnitude. So mana kat sini dia lagi tinggi magnetic field magnitude, lagi tinggi voltage dia. Okey, seterusnya kita akan sambung dengan Hall effect working principle. Okey, Hall effect sensor ni dia guna Hall voltage principle. Hall voltage tu dapat diukur dengan tepat apabila magnetic field tu diletakkan menegak pada 90 darjah ataupun perpendicular pada current flow tu. Okay, electric current ni juga salah satu keutamaan dalam Hall effect theory. So, sedikit penerangan tentang electric current. Electric current ni ialah pergerakan charge particle melalui conductive channel ataupun path. So, dalam current tu dia ada negative charge dengan positive charge holes. Okay, sebagai contoh, mengikut gambar rajah di bawah ni, conductive plate ni disambung dengan bateri, iaitu sumber voltage dalam circuit tu. So bila dia dah disambung, charge carrier yang tadi tu dia akan start untuk flow dalam conductive plate tu dengan one flow dari hujung plate tu ke hujung plate yang lain. Maknanya dari hujung plate ke hujung plate ni, kalau tengok dalam gambar rajah ni kan, dia satu flow je. Okay, dia flow dari satu plate, satu hujung ke hujung tu, dia akan menghasilkan magnetic field. So bila dia dah satu flow ni, dia akan menghasilkan satu magnetic field dalam dekat plate tu. Okay, seterusnya kita akan sambung dengan Ibrahim untuk explain slide yang seterusnya.
The field of the charge carriers will be distorted by the magnetic field of the magnet when a magnet is placed near the plate, which will affect the charge carrier's straight flow in the plate. The force that disturbs charge carrier flow direction is known as Lorentz force. The negative charge electrons will be deflected to one side of the plate, and positive charge holes to the other side caused by the distortion of the charge carrier's magnetic field. So a potential difference, also known as Hall voltage between the two sides of the plate, is generated, which can be measured using a voltmeter. This is known as Hall effect. When stronger magnetic field is applied, more electrons will be deflected. As the current affect the magnetic field of the charge carrier, this means that the higher the current, the more the electrons will be deflected. The more electron deflected, the higher the potential difference will be observed on the both side of the plate which is conducting the current. It can be concluded that the Hall voltage is directly proportional to the electric current, and the Hall voltage is directly proportional to the applied magnetic field.